How long might it take to replicate itself? And you end up with calculations that say that if someone had done that, even a few 100 million years ago, those machines would be everywhere. It's like a virus, right? In a sense, it just propagates. It's an exponential growth of these things. And so you would cover the galaxy in them. And it is true that we haven't observed any. So you might say that that's evidence that nobody ever did it. Or, in the spirit of being scientific about it, you could think, well, yeah, maybe these replicators are the size of a phone. Maybe they're tiny. Maybe they're so advanced that they're in the solar system and we don't recognize them. So you can argue about the Fermi paradox, but broadly speaking, it's the observation that we've looked a bit, and all our observations in the history of astronomy, of all the observations we've made, we have never seen evidence of anyone else. And and it is a paradox because there's been so much time and so many planets, and it would seem as if somebody should have done something that we could see, and they haven't, as far as we can tell.
Research in the Fermi paradox often considers that advanced civilizations might not last long enough to be easily detectable. They may be transient on a cosmic scale, meaning they arise and then disappear due to factors like self-destruction or natural catastrophes. Researchers argue that if technological civilizations routinely self-destroy or otherwise burn out, then the chances of overlapping with our own window of detectability become very small. This short lifetime would explain why we don't see evidence of them today.
Carl Sagan famously said it's possible that civilizations don't get beyond this stage that we're at. So when you industrialize as a civilization, so the pre-spaceflight era or pre-interstellar flight era, you will hit problems which are probably common to all civilizations because they're just part of the laws of physics. So one of them is the challenge you pose to the climate of your planet. As you industrialize and build a bigger civilization, you'll use resources, you will affect the atmosphere of the planet and so on. So there's a challenge and you have to manage that. There's the development of nuclear weapons, for example. So at some point, you will develop nuclear physics if you're going to be a spacefaring civilization. So you will develop the ability to destroy yourself, which is kind of, it's not long. You go back 100 years and we didn't have the capability to destroy ourselves. Now we could choose to destroy our civilization. So it may be that those challenges are very difficult to navigate. It may be just kind of one of those, not quite a law of nature, but a law of societies, that they're just not able to navigate the challenges that industrialization, the development of nuclear science and so on raise. We haven't passed that test yet. So, there's a name for it. It's called the Great Filter. So one of the arguments, so what we're asking here is there a filter that, let's say the filter's in our past. So let's say that it's just the difficult thing is for life to go from single cell life to multicellular life. And that does look difficult, by the way, as far as we can tell on Earth. So maybe that's a filter, maybe it just doesn't happen very much. So there are microbes everywhere and nothing very complex. Then we'd be happy, right? Because we've gone through the filter. But it could be the filter is in our future. It could be that it's now that you get this capability to affect your planet or destroy yourselves through war or whatever it is. That's a filter and we're approaching it. And it could be we don't pass through it. And that would also be a solution to the Fermi paradox.